video Good afternoon, guys. I hope everyone can. Yes. Good afternoon, guys. Can you please confirm, Nikisha? Can you please confirm if my voice is audible?
Yes, sir.
Okay, thank you. And it's the same from everyone, right? Yes. Okay, cool. Hope you had a great weekend. And did you guys study on the weekends? Yes. Okay. NIT Chandrappa. Okay, Chandrapara. Okay. Yep. Okay, cool, guys. Okay, let's wait for a couple of more minutes. Kanishka, I'm audible from others. Everybody able to listen to me? Can you please check from your end? Yes, guys. So, can we start? Confirm once again if I'm audible.
Sir, you're audible.
Okay, thank you, Pratisha. So, yes, guys. So, until the last class, we were like completely like almost done with my ML machine learning. So before we dive into deep learning, I just want to have a recap from each one of you. Okay. So until whatever you are studying now. So starting from the first class till the like last class. Okay. So what did we study? What is the first thing that we learned? Yes, types of ML. Did we directly take into types of ML? Clustering? No. The first class, what did we study? We just had some overview about what is AI, artificial intelligence, yes, introduction to AI, and followed by machine learning, right? And in that machine learning as well, we had this machine learning cycle, right? Like life cycle. We have like around 6 to 7 points, isn't it? right? So what is the first point in the machine learning cycle? Yes, data collection. What is the second one? So you have your data now. Next, what will you do with your data? Yes, pre-process your data, right? So you're going to do all your pre-processing. So once you're done with your pre-processing, what is the next thing? Yeah, ED also to get to know more about your data. Next, you will be selecting your model selection, right? Next is selecting the model. Next comes the training that particular model, right? So after training, guys, are everyone able to hear me, or is it just the Kanishka? Okay, just a moment. Technical. Yes, now let me know if I'm audible to each. Kanishka, and then Deepali. Yes. Okay. Cool, guys. Now, where was I? Yeah. First is data collection. Next is data pre-processing. Next, you want to do some EDA to get to know about what are the data, what is the features that you have. Like you will be exploring what is the data of the data set. Next, after you're exploring, then you're going to consider some pre-processing techniques like imputations, removing some particular column, or filling that missing value with any kind of mean, mode, median, or any kind of standard deviation as well. Next, followed by that, you will be selecting your particular model, right? So once you're going to select your model, then you're going to train that particular model. Once the training is done, you have to evaluate, right? So in evaluation also, if consider about regression, we have a particular metrics, and in case of classification also, we have respective metrics, right? So once you're done with evaluating, then what is the last point? You're going to deploy it. And to bring you the example that I taught you, yes, the last one is deployment. To bring you the example that I taught in the initial class. So I took an example of preparing a biryani, right? I hope you're able to remember, recollect that. Yes, please a thumbs up, or like, it would be appreciated if you have some of to text in the Q&A. Okay. Yes, thank you guys. So we took an example of preparing a biryani, right? So if you're going to prepare a biryani, first thing is data collection, right? Next, first thing is problem statement. You should know what is the problem statement, right? Once you've known your problem statement, then collect all the respective data. That is, bring about all your rice, chicken, beef, paneer, or anything, all vegetables, right? Data is collected. Now, once the data is collected, what you have to do? You have to chop it, marinate it, do all these things, right? So this comes under marination. So once this is done, so you want to select either it can be Kashmir biryani or Hyderabad biryani or dum biryani, right? So these are the model selection that you can consider depending on the type of data or depending on your problem statement. So once you have selected your model, then you have to train it, isn't it? So after you're training it, what you have to do? Meaning training means what? You'll be literally tasting, right, if it is good or not, like almost 80% of your cooking. So there, if you want to check, that comes under evaluation metrics, isn't it? That is evaluating your model. So you're going to see, is the salt perfect, or is it sufficient, or do you need to add more spices? So we'll be checking those kind of things, right? That comes under evaluation. So once everything is fine, you're going to serve it to your customers, isn't it? And you're also going to monitor as well, isn't it? It is not that you want to just serve it and not look after how is your what is the feedback from your customer, isn't it? In a similar way, we're going to do the same thing in machine learning as well. So starting from data collection, so it can be collecting data from any kind of repositories or any, or that either it can be from Hugging Face, Kaggle, or anywhere. Next, once you have that, you have to prepare data pre-process it. Next, in this, to have a clear idea about what your data is, you will be consider this exploratory data analysis, right? Next, in pre-processing as well, you might consider filling up some missing values. Next, if you want to convert a particular categorical variable, that is a textual variable data into numbers, then you're going to use some one-hot encoding, label encoding, isn't it? Yes, encoding. So once that is done, you're going to select your, depending on the type of data and your use case, you want to choose either it can be regression or classification, isn't it? That is model selection. Next, depending on the data as well, depending on the output, if it is a two class output, you want to choose logistic regression, or if it is like multi-class, you can choose the other one, isn't it? So this is model selection. Once you've selected your model, you're going to train it on your training data. So in this training data as well, you're going to split that into 80% to 20% or 70 to 30%. Isn't it? So you will be testing your so once you're going to, if you're going to consider for regression, there are like evaluation metrics, like we have r squared, r squared value, and then we have mean squared error, absolute error. So MSE, RSA and all. Next, coming to classification, we have multiple, just to get to know about the performance of a classification model. We will be considering classification confusion matrix first, right? That includes, it's like matrix, it's like a table where I want to get to know about your prediction, between your prediction and your actual classes, isn't it? Next, to get an overall report about how your classification model is performing, you will get to know about this classification report, isn't it? So in this classification report, you will have multiple metrics like accuracy, precision, F2 score, all these things, isn't it? So that is what we learn, and yeah, that is about the machine learning cycle. And coming to, there were two types, isn't it? So what are the major two types in machine learning? Yes, guys, what are the types of machine learning? Yes, supervised and unsupervised. So what are supervised? Yes, I also forgot about reinforcement as well. Yes, so supervised works on label data, right? Meaning you will be able to map your input with the output. That is a target, right? Next we have so what are the two main what is that topics that we learned in supervised learning? Yes, yes, regression and classification, right? So there were so many algorithms, right? In case of classification and algorithm regression. So almost there were similar algorithms used for both regression and classification, be it for SVM, that is support vector machine. Yes, so linear regression is you will be fitting a straight line based on, and moreover you will be having one independent and one dependent. So that can be called, if to understand that, you can consider an example of number of hours you study and the marks that you get, right? So that is linear regression. So if you're going to consider multiple features, input features, then it can be called as a multiple regression, isn't it? Multiple linear regression. Yes, yes. So what in case of this one? Classification. Yes, guys. Classify the data. Yes, classification is mainly on classifying into different categories, while regression is predicting a continuous numerical value. Yes, yeah, we're talking about the evaluation matrix in case of classification, right? I just told a couple of minutes back, right? So, what are the metrics that you're going to consider? Yeah, confusion matrix, classification report. In this classification report, you will be able to get your accuracy, precision, F2 score, and all these things, right? And then we also started off with unsupervised learning, right? So in unsupervised learning, what are the two things that we learned. One is clustering, isn't it? So what are clusterings? So first, what are unsupervised learning? Yes, not label the data, yet data with no label. Correct. So you will not be having any kind of predefined targets or already defined, already known outputs. So what you'll be doing, you will be finding some patterns or any kind of structure that you can consider. So based on this, you will be able to get some conclusion. Okay. So in this, we had like two main things. One is clustering, and the other one is dimensional reduction, right? So clustering is nothing but grouping a similar data points based on the characteristics into groups, right? Now, other one is dimensional reduction. What is the dimensional reduction? So it is also unsupervised. So what you'll be trying to do is you'll be literally trying to reduce the number of features that you're going to consider for your model, right? So it is a simple example would be, so if you it would be like you can create a dish, okay, with 10 ingredients. That would be good. But what if you have 100 ingredients? So it will be very time tasking. What is it? It would be very taking a lot of time, right? And you will not have a proper target. But if you reduce that, meaning what are you trying to do in dimension reduction? You're going to reduce a particular, you're going to remove a particular, some good number of features, keeping the main things perfect. Okay, meaning you're going to have all the important things in your hand, but leave about all the inconsistent data that you have, or the features that you have. Isn't it? Yes, that is what we have learned, right? So if you see the machine learning cycle, so what we do is, so we use this decision tree, right? So what do? We are going to look for the perfect features, right? Like which is going to come at the node, like the root node, which is going to come at the all the branches, isn't it? So these are all what machine learning. It's like it learns on its own from the whatever the data that we give. So based on this data itself, what we will be doing is we will be telling the computer to okay identify if it has what do you say. Let's consider animal. Okay, if you're going to train a machine learning model to classify between a cat or dog, okay, just identify cat. So what we will do, we initially first predefine. We're going to give them the rule that look for four legs, look for a tail, look for a fur. So these are all the input that we give, right? So that is a traditional method, isn't it? So initially, meaning the inputs or the features will be given from our end itself. But in case of what if you don't have anyone to look after your data, meaning to look after what are the features that you need to understand, okay, that you have to look, then you have to learn on yourself to find the patterns where I will not even give any kind of things to look after to look that you have to look for a particular data. So if you have these kind of problems, then comes the advent of this deep learning. Okay, I think it's clear, right, about machine learning. Guys, now we can directly dig into our uh, deep learning. Just a moment. So yes, guys, can you please confirm me if my screen is visible to all? Yes. Okay, cool, guys. So what are you trying to see in the image that we have? I would like you to first analyze this first image, because as we have learned about this machine learning, right? So I would like to give you a couple of minutes to just let me know what you have understood from this. So I just explained this just a couple of minutes back. Now you tell me from what do you understand by this picture. Okay. Is deep learning don't need human intervention? Correct. Yes, guys. What are all the others? Response for that image? Works easier due to less human intervention was created. Correct. Now, don't get into deep learning now. I'm going to explain that. But given the image, what are you able to understand from the machine learning point of view? Yes, deep learning works easier due to less human intervention. Correct. So looks like neural network can change features. It's not like a neural network can change. Neural network can understand, can find the pattern in the features in the data. Okay. Uh, it does. ML uses algorithm as well. This also is algorithm, but in the algorithm or in the programming, we will not specify what are the features to look for in machine learning. Sorry, in deep learning. But in case of machine learning, we're going to specify. Machine learning need more prompts, the structure from humans. Yes. Yes, Kushi, in a robot analogy, I can take an example of two things, okay, to make you understand this. So let me consider this machine learning, okay, as a smart guy. Okay, let's consider they have students, and you have like two students, okay, and one is what you can consider is like a smart student, and the other one is, okay, just understand this. One is smart student, okay, that is for machine learning. Next is a super smart independent researcher that I can consider. So please understand that I'm going to give the name for deep learning as super smart independent researcher. Okay. So what this person is going to do? So likewise, you can consider they're like deep learning and then machine learning are nothing but like their cousins. Okay. But they do they work independently. Okay. Everyone has their own uh, ways to deal the things with the data that we give. Okay, so let's consider this machine learning. So what we will be doing is let's take an example of we can take an example of we're going to give. So in case of machine learning, and then we had supervised and unsupervised, right? So what we'll be doing here, we were literally giving the question and then answers. That is like supervised, right? And in case of unsupervised, we were giving the whole notebook, so it was able to learn all the things. And we would also mention, so these are the things that you have to consider. Okay, In case of, we can take an example of what do you say, we showing image of a car. Okay, so if you're going to show an image of a car, in case of machine learning, what we will do, we will literally mention that in our programming code what to look for a particular features. Like you can consider the number of wheels, the headlights, the what is the shape of your car, the headlights, like windshield. So these are the things that you will be specifying, right? Isn't it? So these are things that we will be specifying, that we will be mentioning in our programming code, isn't it? Or we need to specify that, isn't it? So this comes under this machine learning, right? So what does the computer do? Computer does, it is going to learn from its data itself. Okay, but sometimes, and like maximum time, it has to have some human intervention for its data. Okay, meaning we have to tell what are the things that we need to, what are the features that the respective model has to consider. By considering that, we will be able to classify, or we will be able to identify, given the features, be it a car or a like two-wheeler. Okay, is it clear? Right, but coming to this deep learning. So what is this deep learning? If you see here, the first one is you're going to input a car image. Next is feature extraction, isn't it? Next, what is that? Then we're going to have this classification. Then finally is our output. But in case of deep learning, what is it happening? Here we are not having any kind of human intervention, meaning feature extraction is done from the deep learning model itself. Okay, so how does that happen? So we can take an example of like we had the super guy, super smart, intelligent researcher, right? So what does he will do? He will not depend on anyone. Okay, so he's like, he doesn't care about the exams and all. He just want to get all the knowledge that he has. Okay, so with the knowledge that he has, he will be able to classify, or he will be able to predict a particular thing, or he will be able to generate a new thing as well. Okay, he will be able to forecast a new things. So what he will do, so we can take an example of to understand this, what is that we can understand. Yeah, you can consider, like let's consider I'm a super chef. Okay, where I have known with all with given any kind of ingredients, I am ready to figure out with the given ingredients, I'm ready to cook any kind of dish. Okay, but in case of machine learning, what does that happen? We have a chef who knows a particular recipe. Okay, and he will only prepare that particular recipe itself. Okay, he might not be able to prepare a new recipe. But in case of deep learning, he will, it's like a super, what do you say, it's like a of what do you say, superb chef. Okay, where just given any kind of ingredients, he will figure out what are the best recipes that he can create by experimenting. Okay, is it clear? And moreover, deep learning is mainly used when you have large amount of data. In terms of large amount of data, meaning like if you have complex data also, if you want to consider, what if you have instead of having table kind of form, okay, table kind of data, what if we have image kind? Okay, what if we have an audio or a video? So it would be very difficult for it to find the complex patterns, right? So in that case, what do we have to do? So we have to get into this deep learning. So what is the deep learning? It is going to work based on the concept called as neural networks. So it is similar to our human, what is that, neuron that we have in our brain, right? So here, what does it happen? We are going to literally train how to think like humans do. Okay, how do like humans think, right? We are going to let the machines also do the same thing. So how are we going to do it? We're going to use this concept called as neural networks. Okay, is it clear, guys? So to put forth the last, I will say that machine learning is a traditional method where you will be training first, giving all the inputs in the code itself, or in the initial you will be specifying what are all the features that you have to consider. Based on this features, you will be able to get some conclusion, be it predicting a particular value or classifying a particular classes, isn't it? But in case of deep learning, it is like literally learning all the knowledge that he has, learning, getting to know about the features that he has in the perfect in its data set. Then based on this, it will be able to predict, or it will be able to generate a new content. Okay, and the data can be anything, starting from images, audio, or text, be it anything. Is it clear? I also took a chef, right? So machine learning can be considered as a chef. So in this chef, he will have a particular recipe, and only that recipe will be prepared. okay, on that particular recipe. But in case of deep learning, so you can consider this like a fabulous what is chef you can consider, where given any kind of ingredients, he will be able to, without any kind of recipes, okay, he will be able to figure out what are all the things that he can cook with the given ingredients. So to do that, he will be doing what? He will be experimenting a lot of things, right? So by experimenting, he will be able to correct all his mistakes, and finally he will be able to generate, or he will be able to prepare a great dish, right? So it is similar to this deep learning as well. Okay. I hope it's clear, right? Any? Yeah, it, like you can consider this machine learning as a like a. It is not like a rule based. Rule based comes like you can consider that you need to specify what are the features that you have to consider at the start itself. Okay, or in your training. But in case of this one, deep learning, you don't need to have any kind of human intervention. What does it happen? Here we have an input. So we will be giving the images. So this inputs are nothing but the pixels that we can consider. So those pixels will be sent into these first layers. These are the neurons. So this will be sent to the particular hidden layer. So this is where our complex patterns will be learned. Okay. So once all the patterns are learned, then we're going to use this classification here, where depending on the type of classes data that you have, you might have, if you have two classes, you can consider sigmoidal or logistic regression, logistic function, or if you have multi-class, you can consider softmax. Okay, so depending on the classification or regression, you can choose the respective algorithm, and based on that, you will be able to predict. Okay, does it belong to this class or in that class? But if you see, you're not doing any kind of human intervention, isn't it? You're not specifying what are the features that you have to look for in a particular image. Okay, so these are inputs are nothing but the pixels from the image. Okay, so these images will be sent to each of these neurons, and these neurons will help you to analyze. So it is similar to our human brain. Okay, just like we have the next slide, right? Yeah, that's what I was talking about. So neural networks are what? This deep learning works based on these neural networks itself. So what are the neural networks? Neural networks are like the building blocks. So it similarly works like your a human brain, right? So if you see, I guess able to say there's dendrites in the nucleus. So this one complete neuron, right? So here the inputs will be given, and finally the output will be shown in the end, right? A similar way, the inputs, what are all the x1, x2, x3 are there, right? So if consider for an image data, these x1 are nothing but this pixel values. So each pixel value will be given assigned to one neuron, and this will be sent to the respective next layer to identify its patterns, or identify what is the data, to understand the complexity in that particular data. Once this is done, then you have to push that using a activation function. Okay, so what is the activation function? Activation function is nothing but it is to let you understand what if you're having not, what if you're not having a linearly separable data. Okay, what if you have non-linear data? In that case, to bring about the solution for that non-linearity, we're going to consider this activation function. So in this itself, we're going to consider, depending on the data that you have, either it can be a binary classification, multi-classification, or any regression as well. Depending on that, we're going to use the activation function and then put that to this based on this value, whatever we get with the adding of addition of activation function, we will be able to know the output. Okay, so you can understand this neurons. So neurons are like the building blocks. It is similar to, that is what we are going to have in each layer. So later we are going to have input layer, hidden layer, and then output layer. So in this input layer also, every layer will have its neurons. Okay, so what are these neurons going to consider? It is going to consider the data. Okay, so what are these data can be? These data can be the what is it? A pixel size from the image. Okay, so any kind of data. So depending on the data, you'll be able to find the patterns in the hidden layers. Okay, so to push from input layer to the output layer in a hidden layer, you need some kind of thrust or some push, right? So that will be done by these weights. Okay, then to push that, you need some activation function. Clear? So if you're going to consider this neural networks, okay, the key component that we're going to learn in this whole deep learning is neurons, connections, weights, biases, propagation functions, and then learning rule. Okay. Now to make you understand this each thing, I would like to what do you say? Give a real life example. You can consider these. I have told you, right? Neurons are nothing but any doubts? Yeah. So what are the first one? So first one comes to the neurons, right? So what are these neurons? So I've told you, right? So these are all the building blocks for our neural network. So what are neural networks? Neural networks are nothing but we're going to have neurons in each layer. So we're going to have input layer, hidden layer, and then output layer. So in the input layer, output layer, and hidden layer, we're going to have all these kind of neurons. But what is this technically a neuron? So neuron is nothing but the what do you say? The information that we give. Okay, is clear. The like you can consider it is where we're going to receive all the inputs. Okay, and it will be you're having your input now. Now you want to what is it? Understand this pattern. Okay, understand this information. So this information or this neuron has to have some kind of weight. Okay, meaning what is the effect of using this particular pixel? How much is the pixel? Okay, if you want to understand this or if you want to find the pattern in this has to have some kind of weightage. Okay, there's some kind of strength. Okay, so once you have your feature, that is your inputs with something with the pixels, followed by if you're going to multiply that with the weights, meaning how much is the strength of that particular input, then you need to push that to the next layer, right, to understand what is that about the hidden layer. So that will be that push. Okay, that will be given by this activation function. Okay, is it clear? So you can consider that as a like a light switch you can consider. So what do? You're going to just receive the input, right? We're going to literally go and switch on the light, like a switchboard that we have, right? To switch on a particular light. So what we will do, we're going to literally go and then give the input, like switch on that particular light, right? So just when you click on that, automatically that is being triggered to the particular bulb and then it is glowing, right? So that is this input. That is comes under this neuron. So next we have these connections. So what are these connections? Connections are nothing but we can consider. So literally you're going that particular light switch is nothing but the neuron that you can consider. That is the input that you have, right? To get your to get that bulb blown, isn't it? So if you want to connect this, so if your input has to come from start from the starting point till the end point, there has to some kind of connections, right? So these connections are nothing but this layers that you can consider. Okay, is it clear? So what are these connections going to do? It is going to connect. It is going to get your data from each layer and then push to the next layer. So initially you're going to have your data from your input layer. So this input layer will be connected to the next layer. That is hidden layer. So why do we have to connect that? It is to carry the information. That is to carry the data of whatever we are having in our neurons. Okay, and here also it is also regulated by or it is maintained or it is carried with some weights and biases as well. Is it clear? So we can consider just like we have roads and all, right? Roads and highway. So why do we have that? To move from one place to another place, right? From one city to another city. The same way, if you're going to move from one layer to another layer, you need to have some. If you need to understand the pattern, you need to follow. You need to go through a lot of connections. Okay. Next, we have this weights and then biases. So what are these weights and biases? Weights and biases are nothing but you can consider how much are these neurons worth. Okay, what is their strength? Like what is their weightage? Okay, based on this weightage, we will be able to judge. Okay, what we can consider, we can consider like given if you're going to classify a particular cat image. Okay, so what is the first thing that you have to look for is you're going to specify the feature more on the fur, right, or the size of that cat image. So you're going to first look at the size of that image, isn't it? So here that size of that image or each pixel will have a separate, okay, separate value for each of the neuron that we has. Okay, and this will also be backed up by a bias. So what is this bias? There is also you can consider a small push, okay, or a small what you can say a fire kind of thing. Okay, you have your input in terms of neurons, which is nothing but this pixels. So this pixels will be Okay, give it to some activation function. So why do we need an activation function? So this activation function, how does it do is, each of these pixels or neurons will have some weights. Okay, based on this weight. Okay, like each pixel will have their its own value, right? Each strength, right? So that is given by this weight. Okay, and also it also does have some biases. So once you have both of these, this will be pushed into our activation function. Okay, so when this is put into our activation function, even if you have non-linearly, or is it linearly, like not linearly separable data points, you can use the activation function to understand the pattern. Okay, so the reason for having this activation function is to have this non-linearity in your data. Okay, meaning it is like, what if you have let's consider you, in case of linear several data points, you will be having two things. You will be drawing a one straight line linear equation of like one straight line, and you will be able to classify between cat and dog. Okay, but what if you want to analyze all the patterns, not drawing? What if you have non-linear data points? So in that case, we have to get to know about, if you want to analyze or if you want to find the patterns, then we can use this activation functions. Okay, is it clear? So if you can consider, so as and when you're going to train your model, these weights and biases will be changing. So why does it have to change? So it has to change depending on the output. So at the finally, we will be having our predicted class and our actual class, right? So if the error is much, so error is nothing but the difference between your predicted class and your actual class, right? So if you're finding a lot of errors, you have to go back and make the changes in the weights. Okay, and biases. Is it clear? Next, we have this propagation functions. So what are these propagation functions? Propagation functions are nothing but, you can consider the data flow. So you can consider these connections as what? You can consider these connections as your wires. So first thing is, you can consider the neuron as your the light switch. That's it. Just the light switch. Okay. Next, we have the connections. So these connections are nothing but the wires that you can consider. Next, we have this weights and biases. So what are these weights and biases? So these are like the strength. Okay, so based on the strength, you will be able to move to the next layer. Okay, now last one, we have this propagation functions, right? So what are these propagation functions? Propagation functions are nothing but like how is your data flowing? Okay, so if you want to flow your data from input layer to another layer, this is where you're going to see it in propagation. Okay, so it is just to say like how, it is just to let you know how the information that is in your network moves through your network, through your whole network, starting from input layer till the output layer. Okay, so a neural network, what it has is, it mainly has three layers. Okay, one is the input layer, that is where you're going to store, that is where you're going to see all your data at the initial point. Next, you have this hidden layers. So hidden layers are where you're going to find all your complexities in your data, that is to processing all your complex things. Okay, so once you have understood, once you have found out all the patterns in your data, then you will be able to get some conclusion with your output layer. Is it clear? Last one, we have this learning rule. So what is this learning rule? So learning rule is nothing but, so each time I have told you, right, you will be finding the difference between the predicted class and the actual class. So here, what does it do is, it will be trying to learn how much has it learned at the first iteration. Okay, how much has it learned at the second iteration? So third time, fourth time. So what does it do is, it is going to change these weights and biases values every often. So why does it have to do? It is to have less number of less error or higher frequency. Sorry, higher accuracy. Isn't it? The main goal that we have to do is that we have to have it in our mind is, it is to reduce the error. Okay, and or we have to increase the accuracy. Okay, is it clear? So to do that, we're going to have this learning method as well. So what are the learning method or the learning rule that you're going to consider? So it is just like you can consider how does it gets better over the time. So time होने के से कितना अच्छा से पढ़ा है हमारा मॉडल, ये दिखाने के लिए हमको लर्निंग रूल पकड़, you have to learn that. Okay, so to summarize it, so we learned about neurons, right? Neurons, connections, weights and biases, propagation functions, and the learning rule, right? So what are these? So these are the like, if consider for the, these are the components if you're going to learn about neural network. So first thing is neurons. So these are all the input that you give. You can consider these decision makers. Next, we have these connections. What are these connections? So these are all the root, or these are all the pathways that you can consider between the neurons. So each neuron, these neurons will be in different layers, be it input layer, hidden layer, and then output layer. So each of these neuron also will have some weights and biases. So this will show that which neuron will go to which layer. Okay. Next, we also going to have this propagation function. So what are these propagation function? It is to show how your information is flowing from one network to the other, one layer to the other layer. Okay. And finally, we have this learning rule. So what does this learning rule? Learning rule is nothing but how does it get us smarter? Okay. कितना smart हो रहा है ट्रेनिंग करके करके. So इसको देखने के लिए हमको लर्निंग रूल सीखना पड़ता है. Is it clear? It's clear, right? So you have your pixel size, right? So weights and biases are nothing but you have your input data now, right? Now you will be having it your input layer. Okay, this input layer, like whatever the neurons are nothing but the input values that you have, right? So these input values can be the pixel values that you can consider. So you have this pixel values. Now you want to understand these pixels. So what are these pixels? It is going to give us. So to understand this, what we have to do is we have to have some kind of weightage. Meaning what? A image ka pixel size kya hai? Pixel, we have this 256 as the what is it, RGB values, right? So depending on this, you will be able to find what is the weight for that particular pixel. Okay, to understand this, you will be pushing this pixel along with this weights into the next layer. How are you going to push that? By using some activation function. To push that, you're going to use this activation function. Okay, why activation function? It is not only if you're having only like if you're having two classes, and if you're only able to analyze if you're able to draw only one straight line. Okay, but what if you're having non-linear data? What if you have image kind of data? Will you be able to classify? Will not be able to, right? So in that case, what we're going to do is we're going to include this activation functions. Okay, so by doing this activation function, what this will do is this first is you will have your pixel size. So these pixel will have its own weightage or the strength that is given by this weights and then biases. So once you have all those things, this has to be pushed to the next layer, that is the hidden layer. So hidden layer is where we are going to learn all our, what do you say, patterns, understand all the knowledge, get the data, insight from the data. So once you have your data in your hand, once you have understood what is your data about, then with this in your hand, you will be able to classify between classes. Okay. Please provide the PPT slides. Just, I'm not telling, I'm just recapping us there. Huh? Is it clear about all these things? About the key components? Now, next comes the single perceptron and then multi-perceptron. So what are the single perceptron is? It is just you're going to have, so first understand this neural network, it is going to have, yeah, it is going to have all these things. Mainly, what does this deep learning will have is an input layer, hidden layer, and then output layer, right? So if you're going to have one input layer and then one hidden layer and then output layer, where you're going to have only one thing, okay? Like in one way you can consider, meaning one, if you have only one hidden layer, you can consider that as a single perceptron. But what if you have multi-layer? Okay, it is to what if you, in this case, you will be able to identify only one pattern. Okay, इधर तो एक ही feature को हम पढ़ सकते हैं, but in case of here, we will be able to having multiple layers will let you to understand all the other features as well in your data. Okay, is it clear? So single perceptron is it is like you can consider as like only you will have one what do you say input hidden layer, but in case of multi-layer perceptron you will have multiple layers. So just by having this hidden layers itself, they are able to get this term called as deep learning. So if you have more hidden layers, so more hidden layers are nothing but you can consider this is where you will be, what do you say, you will be able to analyze, or you will be able to know the depth of your, or you will be able to get to know all the intricate, all the small details about your data. Okay, meaning what, you will be able to, even if it is a simple data or if it is a complex patterns as well, complex data as well, you will be able to find that pattern. Is it clear? Any doubts, guys? Water. Okay. So where was I? Yeah, I was in perceptron. So we can take an example of, so what do we have here? Here we have only one input, one hidden layer, and the other one is you have the output layer, right? You can take an example. You can give the input as you put in a fruit name, okay, and you're going to specify only one thing. What is that? You're going to have only if it is a, if this is a sugar, it's a sweet, okay. If it has a sugar content heavy, then it's a sweet thing, right? You're giving only one thing, isn't it? And output can be, it can be sweet or not sweet, isn't it? That is what you can consider. But in case of hidden layers, what you can consider, you can consider multiple hidden layers. So what are these multiple hidden layers that you can consider? You can consider multiple features, okay, based on, if you want to analyze, what do you say, not only the what is it, sweet content in the fruit. If you want to analyze if it is a mango, or is it a ripe, or is it from India, this will not will happen. But if you want to understand more about your image, okay, more about your image, you have to get to know about your pixel values, right? All your pixels. So if you want to analyze, or if you want to get to know about what is your image and all, you need to have these more hidden layers. Okay, so hidden layers is where we're going to analyze what is our data about. Is it clear? These are all the x, the pixel value that we can consider. And if you see, these are all the connections that you have, right? So each of these, okay, will be connected to the next hidden layer. So if you're going to connect, if this neuron has to go to this neuron, this is in the hidden layer, this has to have some kind of push, right? First, this neuron will have some weightage that will be given from weights and biases. Okay. Now, once it has, this has to be pushed to the next layer to understand this data, right? To understand the pixel. So this is done by using this activation function. So depending on the data that you have, okay, if it is a negative value, it is going to, by using a remove function, it is going to remove that particular neuron, meaning it doesn't have much impact. Okay. So we have so many, what do you say, activation functions. But to give you just the difference between the single perceptron and multi-layer perceptron is, you're going to have only one kind of hidden layer. But in case of multi-layer perceptron, you're going to have a lot of hidden layers. So this is where our most patterns, like most patterns analysis will be about the data will be known. Okay, since you're going to have more number of hidden layers, and hence this deep learning method. Okay, right, it's clear, guys. 3 o'clock. One break now or a couple of minutes later? Is it clear, guys, about single perceptron and then multi-layer perceptron? Yep. Just understand that all the things, or all the things will be learned in the hidden layer itself. Okay. And to push the data from input layer to the hidden layers, you need to have some weightage. So based on this weightage, you will be having the activation functions. So this activation is going to check in, based on the weightage that it has, based on the value that it has, where does these neurons has to go to the next layer's neuron. Okay. Yes, guys. So let's, we have layers, input layer, hidden layers, and output layers, and activation functions. Okay. Okay. We'll take a one quick break. Then we can start off. Okay. I have told you now itself. Doesn't have much. Don't need much of this introduction now. Okay. Which we have activation functions. Okay. Yes, guys, you can take a break for 10 minutes. And then we can start off with class later. Okay. We can resume it later. Yes, guys, please take a break. I'll share the notes by end of the day. Okay. Okay, guys, take a break for 10 minutes and then we can resume the class. So, yes, guys, can I resume the class? Does deep learning need cleaning the data? Yes, it does. Because machine has to understand, right? Through our naked eye, we will be able to tell what the picture about, but how the computer is going to understand. And initially, it has to find all the pixels that it has in an image, right? So what if you want to analyze, or what if you want to predict, only focus on the cat image, not the background? So those are all the noises that you have in an image, right? So you can remove that as well. Yes, I hope it's clear. Let me share my screen. Now, no disturbance, right, in the class? And can you guys confirm me? Any sounds or any disturbances?
No.
Okay, thank you, Pratisha. No, we have learned about this one, right? So what are the first one? So first one is like our input layer. So this is where we are going to look after our where we are going to inject, or where we are going to push our initial data, right? So I have clearly mentioned in the points wise. So what is the first point? The first point is like the first layer. So that is the starting point where you will be getting the data. Okay, isn't it? So you can consider like your you can consider. So if anybody want to get into your home, the first it is like entering into your main entrance. Okay, it is like a main gate that you have, right? So based on that, after you pass that gate itself, you will be getting into your home, right? In a similar way, if you want to get into your home or any kind of building, so this is like an entrance where this is like an initial place, or this is like an initial thing where you will be giving all your inputs. Okay. So now, so what does this input layer is going to do? It is going to get all your raw information. It's clear. So raw information meaning what? You can take an example of what if you're going to go for a, what do you say, a restaurant. Okay, so this, if you're going to consider this restaurant as your whole building or a thing to be done, and this input layer can be called as a waiter. Okay, so what does this waiter is going to do? He's going to request, or he's going to he will be expecting the order from the customers, right? And once the order is given, is the waiter is going to go and then prepare it and then give it to you? No, right? He's just going to get your input or get your order from the customers, isn't it? So you can consider this input layer as like your place where it is similar to the waiter. So you'll be waiting for this customer's order, right? So he will not be preparing anything, isn't it? Meaning he will not, this input layer will not be doing any kind of analysis. It is just that it is going to just inject, or it is just going to have the data at the first time. Okay, is it clear? And if you see, so each neuron you can consider. So it is not like you will have only 5 neurons or like 10 neurons. So here neurons are nothing but you can consider the raw information, the pixel size that you can consider in case of image. Okay. Now you can, it is similar to you, what do you say? Like each neuron will have a specific data, right? So these data can, if you have, let's consider if you have 10 features in your data, okay, like 10 pixels. So you might have, let's consider you have a picture of size 10 pixels, okay, in what you can consider 10 in width and 10 in length. So what does it consider? You're going to have 100 neurons. So each of these 100 neurons will have a specific value for each of these pixel size, right? So pixel matlab kya hai? It is the what is it? Color. Okay, so each of the color will have some its values. So all of these values is going to range from 0 till 256. So with this combination, with this 0 to 256 itself, you are able to get all your different types of colors, right? And we also have this RGB, that is red, green, and then blue. So with this combination, with these three in combination, you can do wonders, or you can create so many colors. Okay, so here what do we हमको क्या समझना पड़ता है, मतलब in input layer, we're going to have all the neurons. So what are these neurons? These neurons are nothing but it is like a person who's going to hold some piece of information about your data. Okay, so you can consider this piece of information or a feature you can consider. Okay, and since I've told right, as the waiter, he's not going to prepare you. जब हम वेटर को एक आइटम पूछने के बाद we does he going to go to the kitchen and then prepare all the food and then give it to you? No, right? He's just going to get the data and then give it to the kitchen, isn't it? So this is also the same thing, meaning he will not do anything. He will not do any kind of analysis. Okay, meaning they will not do any kind of calculations part. Okay. Next, what are the next one? We have this pixels in picture. What are these pixels in picture? That is what I was talking about. So let's consider I have a picture. Okay, black and white picture. I found like 10 pixels in white, and the other one is 10 pixels in tall. Okay, so what does this each input layer will have? So input layer will have around 100 neurons. Okay, and each of these 100 neurons is going to represent a 1 pixel value. Okay, and what are these 1 pixel value? Or nothing but each neuron itself, right? So each neuron will have its own value. Okay, either it can be, this pixel can be of what do you say, red RGB. Okay, that is red, green and blue. So depending on the combination of these, you will be getting a particular color. Okay, is it clear or not? And once you have the data, are you going to stay with your hand? And once it is similar to the waiter itself. So जब हम waiter को like order बोलने के बाद, does he really stand there? No, right? This information has to be given to someone, right? Isn't it? So this information will be sent to the next layer called as this hidden layer. Okay, is it clear or not? So to simply put, like to give you a summary, so you can consider this input layer as what? It is the first part. So this is the starting point for your whole neural network. And what does it do? It is going to receive all your raw information or raw data that you have in your hands. Okay, so each neuron will have a specific piece of data, right? So what are the specific bit of data? It is the value of each pixels, isn't it? And you're not going to do any kind of processing, or you're not going to do any kind of calculations, meaning you're not going to find any kind of patterns, analyze any kind of your data. Okay, you're just going to have your data and push this data, whatever you're having in your hand, you'll be pushing these from input layer to the next layer. Okay, so in the next layer, you will be analyzing what is your data about. Is it clear? Is it clear, guys? So next we have this hidden layers. So hidden layers is where the actual magic comes. Okay, so what is this actual magic? So you can consider, so I took an example of waiter and then chef, right? So waiter and then kitchen. So waiter you can consider as an input layer. Why? The kitchen you can consider that as your hidden layer. So why kitchen is a hidden layer? Because that is where all the, what you can say, all the great dishes being cooked, right? Like all the magic happens there itself. What? You're going to have all your raw materials. You're going to have your ordered like order from your customers, and each of these orders will be turned into a delicious meal. Okay, in the kitchen itself, right? It is similar to this in case of hidden layers as well. So mainly this will be between the input layer and the output layers in our neural network. Okay, so and main important is this is the core part. Okay, this is the important part where we're going to analyze, or where we're going to find all the hidden patterns and the complexity in our data. Okay, that's clear, guys. So at the initial what do you say, in input layer, we were not having any kind of calculations, right? Even we are not worried about to understand about what is the data about, but you will be able to understand what is the data about, what are the patterns that you have. Everything will be done, and all the calculations will be done in this hidden layer itself. You can consider this like a thinking, it's like a thinking place. Okay, you have your data now, but what are you going to do with your data? Okay, how are you going to analyze? How are you going to think about what is the data about? So everything happens here in this hidden layer itself. Okay, so that is like actually what are you thinking and what are the analysis that you're going to do for a data. Everything happens in this hidden layer. Okay, so we can consider this. We have this and then detective, right? Detective agent. So what does it do? So he needs to have all the inputs that it has. Meaning, once a murder has happened in some place, so he will collect what? He will collect all the inputs. Okay, be it from what you say, a person's clothes or a hair or a used any particular item. So he will collect all these data, right? So once he collects the data, so what is it going to do? He has to analyze, find some patterns, right? So this analyzing and finding the patterns, thinking and all is done in this hidden layer. Is it clear? Is it clear? So if you're going to consider, you can consider having this. Why do we have to have this many layers? So it is to, let's consider you're going to do a project. Okay, so if one person does a project, it takes a lot of time and it would not be that great. But what if a project is done by multiple people, like in a team, not an individual project but a group project? So which will be more efficient? The team project will be more efficient, right? Because each person will be contributing a particular part, isn't it? And the work will also be completely done completely super, yes or no, completely super work or efficiently it would be done, isn't it? So the same way here as well. So if you're going to consider like a more number of hidden layers, you will be what do you say? You will get to learn all the complexities in your data, all your small hidden pattern that you have in your data. You will be getting to know. Okay, and here as well, if you're having some kind of a small data, okay, like just like we have this 100 pixels, right? Like 10 pixels in wide and 10 pixels in length or tall. So if you're having that kind, you can have this less number of hidden layers. But what if you had 1000 pixels? Okay, what if you have 2000 or 4000 pixels? Now, if you want to analyze all those things, you definitely need some what do you say, a big team, right? Big team in terms of more hidden layers, isn't it? Yes or no? Next, so once you have your, what you can say, once you have your this in your hand, that is your many layers in your hand. First thing is you will have everything will be moving from one place to another, one layer to another layer, depending on the weights in each of these neurons. Okay, so what are these weights and neurons? Weights and neurons like bias are nothing but the strength. Okay, so you have strength. Now you need some push to go and then analyze more about your new data, that is the pixel size. Okay, that is done by this weights and biases. So why do we need that weights and biases and all? It is to just understand more intricacies in your data. Okay, from in input layer you just want to give your data, but in hidden layers this is where you're going to analyze what is your data about, right? Isn't it? So that if you want to understand what is the value of that, what is the pixel size, what is the pixel size that a particular input neuron has, so everything will have its own weightage. Okay, so that weightage is nothing but this weight that we have. Okay, so yes, to put forth, you can consider this weights are like here. It is that you're going to find the strength of your connection. So it is to know the strength between one layer to another layer, from one first hidden layer to the second hidden layer. Or not only that, you can consider from input layer to the first hidden layer. Okay. So next, the last we have is adding the activation functions. Right. Okay, so last one we have is, what is the last one we have? We have the adding the complexity, meaning what? So if you want to analyze or if you want to understand the complexity in your data, then we're going to have this activation function. So why do we have to have this activation function if you don't have this? So even with so many, what you can say, layers, the network, whatever we have, right, will not be able to, what do you say, only it will be only able to have understand the linear relationship. Okay, if you're going to have just like we have the single perceptron, what did we have here? We were not able to find any kind of, what do you say, find the different kinds of firstly single perceptron had only one hidden layer. Okay, that is if you're going to classify between, if you're going to find some relation which are like linear in relationship, okay, then it's good. But what if you have multilinear, like what if you have like non-linear relationships? Then if you want to understand that, meaning what, if you want to understand the, what are the curves in your in an image, okay, or the patterns or the complicated relationships in your data, okay, to understand this, not only your straight lines, okay, if you want a straight line you can have so many things, you have single perceptron. But if you want to understand the non-linear relationships, then we have to understand this activation function. Okay, so we're going to use this activation function just to bring about this non-linearity. Okay, is it clear, guys? So to just put you a simple example, I've told at the start, right? So waiter is your input layer. So hidden layers can be called as your kitchen. So kitchen is where the inputs will be given, where will be the chefs, and he will be preparing all your delicious meal, isn't it? That is in the hidden layer. So what is the output layer? So output layer is nothing but what? This is where the waiter gets it from the kitchen, isn't it? So that is this last layer that we have. So what does it do? It is going to show you just the predictions of the final results. Okay, so whatever has happened, or whatever all the analysis that it has been done uh, in our hidden layer, that will be shown in our output layer. Be it can be classifying between classes, okay, or predicting the particular what do you say, how many number of neuron that it has. And here also, if you see, we have the sigmoid and then softmax, right? So sigmoid and softmax are nothing but these are all activation functions. Okay, so you will have some data in your hand. Okay, so we are going to use this. We also did come across this term called as sigmoid, right? Sigmoid function. So where did we learn the sigmoid function? First, understand this. So last layer is where we're going to see our output. Okay, and now coming to the sigmoid and then softmax. So yes, guys, where are you? Yes, where did you guys learn about the sigmoid function? Yes, logistic function, right? So what did you learn in this logistic regression? This logistic regression mainly comes under classification, right? But why do we have this regression name in this logistic regression? Although it comes under classification, it comes under classification, but why do we have regression name? Binary outputs. Yeah, binary outputs means classification, right? But why do we have this regression? Yes. So you're going to have the values between 0 and 1, that is probabilities. Right? You will have some threshold. Based on the threshold, you will be specifying if it is closer to, if it is above the threshold, it will belong to one class. And if it is lesser than the threshold, it will belong to another class. So this will have a function, a sigmoid function, where this sigmoid function is 1 by 1 minus e power z minus z. That z is nothing but the combination of your what do you say, your slope value, that is b1 b0 plus b1 plus x1 b0 to b2 plus x2. So the x2 and x1 are nothing but the input feature that you have, isn't it? So b0 b1 to or the b1 b2 are nothing but the slopes or the coefficients for your features that you have, isn't it? Yes or no? So once you have this and find some particular value, this has to be pushed into our sigmoid function formula. So once you want to push its z value into a sigmoid function, you will be getting the answer in terms of probabilities. Okay, so these probabilities, if it is whatever the answer that you're going to get, if it is closer to 1, then it belongs to one class, and if it is closer to 0, then it belongs to the other class. Okay. Yes, so here as well, in case of our sigmoid function, so what we're going to do is, if you're going to classify between two categories, okay, so that is what we used to have this logistic regression, right? The output will be in terms of binary classification itself, isn't it? So this way you will be using at the output layer. Please understand that. So you will be having this things. Okay, one is sigmoid function and the other one is softmax. So why is sigmoid is, if you're having to find between two classes itself, either cat or dog, okay, then you're going to use this activation function called as sigmoid. Next we have the softmax. So why do we have the softmax? Softmax is nothing but if you're having multi classifications, meaning if you're having multi classes or multi categories, okay, be it classifying between a cat, dog, and then bird. Okay, so here the classes or the categories are more than two, right? So in this case, you will be having this softmax as well. Here as well, you will be having this range. Okay. Now, to understand this activation functions, so what are these x1, x2, and xn are? These are all are pixel values. So each of these pixels will have some weights. Okay. So once you have these weights, this you have to, what do you say? Everything has to be multiplied. Okay, with weights and then each input value. Okay, x1 and then x2, and it also have some biases. Okay, so why do we have to have this bias? So this is to have, why do we have to have this biases? It is to push this whole this input, this neuron. A neuron हमारे पास है ना x1, this is a neuron, that is x1. So this will be multiplied with our weight. Weight मतलब क्या है? ये x1 का, ये neuron का weight कितना है, इसका strength कितना है? That will be shown by this W1. Okay. Now in a similar way, you're going to calculate all the one for the remaining pixels as well. Then you will be adding that bias as well. Okay. So once you have this, this has to be put into a activation function. Why activation function? It is to bring about this non-linearity in your data. Okay. So once you have put that, so there are so many activation functions. ReLU we have, sigmoid we have, tanh we have softmax we have. So depending on the output, you will be able to predict the, depending on the result that you get, you will be able to predict the output, be it a cat or a dog or a bird. Is it clear? So this is just an activation function. So why do we need an activation function? We need an activation function just to activate. So whatever activate meaning to push this data, whatever you have between your neuron and its weight to the next layer, you need some pressure or you need some thrust, right? So that will be given by this activation function. Okay, so there are the different types of activation functions, like we have sigmoid function, tanh function, ReLU function, softmax function. Okay, so now let's understand why do we need to have this activation function. First, let's understand this what are activation functions. So what are these activation functions? I've told you, right? So these are all the mathematical functions. So you will have your what is that, combination of your input values followed by your multiplication of your input value, that is x1, multiplied with weights and added with the bias as well. So if you're going to include all those things, then you will be able to find this activation function. So how are you going to find it? You're going to have particularly consider there are multiple activation functions. Just by putting the z value into that, it is going to show you, meaning it is going to guide which neuron the input layer में पहले एक neuron रहेगा ना, वो a neuron in which hidden layer में जाना, hidden layer में भी neurons रहता है. Hidden layers में the neuron that we have in what is that, in hidden layers, we will be able to guess based on this activation function itself. Okay, and most importantly, I was talking right. So activation functions are mainly used for you to bring about this non-linearity into your network. Non-linearity is nothing but rather than finding this linear relationship between your data, you will be able to find all your patterns like intersect and complex patterns in your like non-relationship. Okay, non-linear relationships. If you want to have it, then you can have this activation functions. Okay, yeah, if you see here, without this activation function, how does this neural network is going to do? It is going to work like a simple linear regression model. So in simple linear regression model, what do we do? You want to just draw a straight line, right? That is going to best separate two classes. But what if you want to analyze or find all your pixel size? It takes a lot of then you have to come out this nonlinear regression model, right? So to understand that, we are going to have this activation function. Okay, and how do they do? They're going to decide if a neuron should activate based on the weighted sum of inputs plus the bias. That is what I was talking about. So what was it talking about? What is your neurons value? उतना value कितना है, उसका strength कितना है, उसको देख के we will be able to activate to the next layer. Okay, next layer मतलब क्या है? Input layer से hidden layer. Yes or no? So कितना क्या क्या न्यूरॉन जाना है नेक्स्ट लेयर को, that will be dependent on the weighted sum of these inputs plus the biases. Okay, but why do we have to have that? So first thing is, it is going to use the neural networks. It is going to use the weights, biases and activation function in each neuron. It is not that it is going to only use it for a couple of neurons. It is going to include for all the neurons that we have, Okay, so meaning what? You first it's going to find the sum of these weights and biases, then that will be added to our activation function for each neuron. So why do we have to have that activation function? It is to let the neuron know that it has to go to the next layer in particular neuron. Okay, and most importantly, we have this back propagation needs gradients. So what is this back propagation? So back propagation is nothing but it is to what do you say? You will have your error right between your predicted class and the actual class. Now you will be having this error. Now we want to go back and then change what? You can go back and then change the weights and biases, not the pixel values. Is it clear? Now if you're going to do that, what you're going to do? You're going to go back and then change the accuracy. You will be trying to change the accuracy, isn't it? Or you will be changing to have less number of error. Is it clear? Next, problem with non-linearity, right? So without deep neural networks, we will not be able to analyze a particular pixels image because there will be so many patterns, right? There will be so many pixels. Next, then the power of nonlinear activations. So there are so many activation functions, that is nonlinear activation functions. We have sigmoid, softmax, and so many of them. So why do we have to have that? If you're having linear relationship, we have this simple linear regression model. We will be able to classify them, okay? Or we will be able to find a straight line that best separates the two classes, or we will be able to find the next outcome. But what if you have complex relationships? Okay, so in that case, we will be having this non-linear activation functions. Okay, yes, guys, are you guys making a note? So here we have types of activation functions are, we have sigmoid. So as everybody knows, so sigmoid function is an S-shaped curve and you will have the ranges between 0 and 1, isn't it? And it is mainly used for binary classification. That is what we were able to do, right? So we will be having the sum, what is it, weighted sum between your input values and your weights, isn't it? So this will be, this will have the application from the activation function, and this activation function is going to let the neuron know that at what layer that this neuron has to go. Is it clear? So here as well we have a formula called as 1 by 1 plus e power minus x. So what does this e power minus x represent? These represents nothing but the weighted sum between your weights. Like each neuron will have its weights and its bias, right? So this is the sum. So once you have this, you will be able to find, does, after applying the sigmoid function, does this neuron has to go to the next layer or not? Does it have the respective value? Does it has much a value to push that into the next layer or not? That depends on this sigmoid value. Okay, and it is mainly used for sigmoid function, and it is mainly used for like binary classification, as we saw in our logistic regression as well. Next, we have this tan h. So if you're having a value, so whatever the value that you're going to get, right? So if you're getting value between -1 to +1, okay. Now, what do you have? Why do we have to have that? Is it is only to find a non-linear. What is that? Non-linearity in your pattern. It's non-linearity in your data itself. Okay, meaning what? If you're having so much of patterns or so many of pixels that is not at all able to, that you're not at all able to understand it, then you can include this tan h. So by doing this, what you're going to do is you're going to have this. It is also similar to this sigmoid function, is it? But it is what you can consider. It is clearly mentioned, right? It is shifted vertically compared to the sigmoid, isn't it? And here also the formula changes. Okay. And if you see here, it is zero-centered output. So what does it represent? What does it represent? It doesn't have to. Right. So what does it have to do? So it makes, you're not going to have any kind of zero value. So it will be there between -1 to +1. Okay. So you don't have to worry about if it is, if you're having any kind of values close to 0. Okay. You just have to find if it is closer to -1 or +1. So next we have this rectified linear unit function. So this is very, very important. So whatever the, so this will be taken in all our, what do you say, hidden layers. Maximum it will be done used in our hidden layers. Why this hidden layers is because whatever the value that they're going to get, Okay, the x value that you're going to get, it is going to consider the positive value itself. So why only positive values? So if you have a neuron which is a negative value, it is worthless to consider that, right? Negative का तो उतना में ज़्यादा मतलब नहीं रहता है ना. So इसलिए what we have to do is we can remove that, okay, and consider only the neuron that has most important, that is a value greater than 0. Is it clear? So if you're going to have any kind of negative values, then that particular neuron will have a value that is 0. Okay, and here as well, the range is between 0 and till infinity. Is it clear? So make sure, guys, this is very, very important, as when whatever the output will be of your function, if you're going to put that into ReLU, so what this will do is, so you're going to have this weighted sum of your neuron, right, between your weights and biases. So this value will be known. After knowing this itself, हमको पता होता है if the value is greater than 0, okay, then that has to be pushed to the respective next layer with the neuron. Okay, or if it is not, it is better to give a value as 0. Meaning what? If you're having a neuron with negative value, it will not have any kind of importance, right? So it is to remove that. It is better to remove that and consider the only value that it has positive values. Okay, that is what we're going to do in our by using this ReLU in our hidden layers. Okay, so we're going to remove the unimportant or like worthless neurons that has value 0 or negative values, and consider only positive values. Okay, so lastly we have this softmax. So what are the softmax? Is mainly used at the output layer. Okay, why in the output layer? Because if you're having multi-classification problems. Okay, so I've told you about this one, right? We have this. What if we have 5 classes or 3 classes? Now we want to find the, and most importantly, you have to understand that it also, just like we have this sigmoid function. Okay, sigmoid function is meant for what? It is to give you the output in terms of probabilities between 0 and 1, right? And it is used for binary classification. Similarly, if you want to have multi-classification, okay, this also gives you a range between 0 to 1 itself. So depending on different classes. Now if you see this diagram, you're able to say this output layer, right? 1.3, 5.1, 2.2, 0.7, 1.1. Yes or no? So these are the vector value that you have. Now, if you put all of these into these softmax function, okay, so what this will do, this z is nothing but these values, right? So if you going to put this is going to give you the probabilities of how much this each neuron will have the classes. Like if you're going to consider 1.3 put into this value, you're going to have this 0.2 class 0.2%, that is 2% of this whole data is about this one, and 90% of the data is about one class. 0.5% of this 2.2 given a value is of 5%, and 0.1 is of 0.7. Okay, and 2% is of like 1.2 neuron. So these are all the values in each of the on output layer. Output layer में हमको रहता है, yes or no? So this output layer will be pushed into this one activation functions of max function, and this will ensure. So this will give you the probabilities values. Okay, so whichever has the maximum, what do you say? What is the maximum value in the probability that belongs to the particular classes. Okay. So this is very, very important, because this you will be seeing at the end. Okay. For each, you will have this input layer where you're going to give your input. Next, you will have hidden layers. That is where you're going to find all the patterns. Then finally, you have the output layer. So output layer is where you're going to give the result, right? So giving the result as well depends on the use case that you have. If it's a 2 classes, you can consider sigmoid. Okay. Or if you have multi-class classification, you can consider softmax. Okay. Is it clear, guys? Ma'am. Yes, yes. We provide the notes, right? Because notes means board for reading and watching. Structure and ranking which we can read and topics. Yes, we are not allowed to share with you the PPT contents, but whatever I'm teaching, right, I'm sharing it in the document form, right? I'm not clear about how machine learning is available yet. Okay. To understand you this, okay, to make you understand, okay, we have heard about this iris data set, right? That is classification of different flowers, iris class. Yes or no? So in case of label data, we can have all the petal size, petal width, sepal length, and all, right? And at the last, you were able to find what were you able to find? You were able to find the different three classes, right? 0, 1, 2, isn't it? Now that comes under label data. Now, what if you didn't even provide that last column? That is the target. Now we are not even giving that last column. Now the machine has to learn, right? Yes or no? So that will be done when you're going to use this concept called as k-means clustering we had, right? Yes or no? So by using the k-means clustering, we will be able to identify, depending on the each input that we're going to give, everything will give you an output, right? At the last, you will be getting some pattern, isn't it? So for finding that k-means clustering as well, we had centroids, right? Yes or no? So initially we might consider randomly any two centroids, like any three centroids. Some based on these three centroids, we will be finding the Euclidean distance, right? So whichever the distance is very less, you will be consider the particular cluster, considering that particular data point, that particular cluster, right? So you will be doing this until you're not going to see any change in the cluster. That is the data point that you have, right? That is what you are doing, right? Unsupervised में हम क्या करते हैं मतलब we will not give any kind of outputs, okay, but similar to iris data itself. So in case of label data we will be providing, but what if you don't even provide this last data, last column, or like a target or the label data? Now we have to find the patterns, right? So in that case we are going to use this clustering technique. Okay guys, did you understand Kushi? So I have a solution. It's not allowed to share the content. Okay, the PPT is that appealing? The PPT is giving you that much of content. Rather than the PPT that I have, I'm giving more content, right? Okay. Okay, let me try from my end the maximum. Okay, if possible, I'll share all of the content. Okay, PPT slides. And make sure if shared, please don't share it with any of your fellow mates. You can do some edits and then share it to you. I think the notes would be better. I think I understand that PPTs would be more informative and attractive to make you understand within an instant. But whatever the PPT slide that I am going to that I am teaching every day, I'm putting the same thing into the document form, in form of like notes. The least thing that I would expect from each one is, I literally forgot to mention this, just take 20 minutes of your time every day, or whatever you have done and studied, right? Just take 10 minutes. Okay, we have ample amount of time every day to whatever we have learned, and just make just have a skim or just have a glance at whatever we have learned in the class. It's just for maximum 10 minutes, not at least, it is at most. Okay, so whatever the data that I'm going to share, whatever the content in the note that I'm going to share in our drive folder, just have a look at for maximum 10 minutes. Okay, that is the only thing that I'm going to ask. And if you're having any kind of trouble, even after reading the content or even after going through the notes, please come back in the next class and then ask the doubts. Okay, don't forget to ask the doubts. I hope it's clear, right? So spend 10 minutes of your 24 hours every day just to go through the notes, whatever you have done or whatever I am going to share. Okay. I hope it's clear now, guys. Tomorrow we're going to learn about feed forward neural network, back propagation, and gradient descent, and then finally dive into CNN, convolutional neural network. Okay, so tomorrow we'll try to complete CNN and also do the coding part as well. Okay, CNN is very what is it? Fun. It is very what do you say? Cool stuff. Everybody can understand it very easily, and the subject is also very nice. CNN, because it is mainly going to what is that? Focus on the images data itself. Okay, the grid-like structure, nothing but the images that you have. So if you want to analyze or if you want to find the classes between the images that you have, you rather than specifying a particular feature in hand start itself, the hidden layer will be able to analyze. It will be able to find all the patterns, or it will be able to find all the pixels. Okay, based on that it will be able to classify between classes. Okay guys, that's all from my end. If you have any queries, just do let me know, or else we can wrap up the session. Yes, thank you, Jane. Thank you, Pratisha. Yes, guys, if you have any doubts, just let me know. Or if you have none, please mention the same in the Q&A so that we can wrap up. I hope everyone understood of today's topics, right? Yes, okay, cool, guys. So you do one thing, you go home, spend at most 10 minutes of your time, and I'll try to upload it by end of the day of whatever you learned until now, and make sure you have a glance at that. And after you having a glance, and if you're not able to understand, please do come tomorrow and then ask all your doubts. Okay. Yes. Yeah. To be precise, it was mostly on the artificial neural network itself. So I've shared you the document folder. What is it? Our drive folder, right? So yes, tomorrow we're going to learn about CNN, convolutional neural network. I've shared all the notes. You can do have a glance at that. And one more thing, guys, please have your presence in the in the class for at least 30 minutes without having any kind of interruptions. If you're not going to be at least 30 minutes, your attendance will not be considered. It is like if you're going to come back, if you're going to be in the meet for 15 minutes and then you're going to join the 16th minute, it won't happen. Okay, you have to be at least be in the meet without having any kind of interconnection, not having, what do you say, without having any issues. You should be In the meet, you should be in the class for about 30 minutes. If you're not having that, you're going to lose your attendance. Okay. Yes, guys, I hope it's time up. So thank you so much, guys. We'll see you tomorrow. Okay. I'll make sure I upload the content by end of the day. We can have a class at it. Okay, guys, thank you. Bye bye.
Thank you, sir.
Thank you. Thank you, Pratisha. Yes, bye, guys. So please make sure to spend 10 minutes of your time, and we can meet tomorrow, guys. Enjoy your day. Bye bye.